Until now, we have used only sigmoid function as an activation unit. We already know there are two steps to find the activation unit output. One is Z and the second one is to find the sigma of Z. Now I am thinking this Z is okay because the concept of the neural network is same for every layer. Whenever we want to find the Z, we have to multiply the input feature with the W. That is okay. But is it possible to change the sigmoid function to any other value? Can I take any other function? Yes, there is a possibility. Now we are discussing about the tan H function. This tan H function output is ranging from -1 to +1. The tan H of Z is e to the power Z minus e to the power minus Z by e to the power Z plus e to the power minus Z. Our sigmoid function output is ranging only in between 0 and 1, but this tan H is ranging in between -1 and +1. But remember, we can use this tan H only for the hidden layer activation units. The last layer activation unit output must be in between 0 and 1. So even though you use the tan H for the hidden layers, the last layer must be represented by using sigmoid function only. There is another function called ReLU, rectified linear unit. Means here you can observe it is appearing as a linear. What is the need for it? When we are taking the previous functions, whether it is sigmoid function or tan H function, after a certain point its slope is becoming 0 because those two functions are behaving as constant outputs functions after a particular value. Because of this, sometimes whenever I am changing the Z value, the output is not at all changing. But when I take the linear function like rectified linear unit, its slope is not becoming 0 after a particular value. That's why we can prefer this in the hidden layers. Whenever we want to, we are expecting the slope should not become 0 for the Z values. Whenever we are increasing, then we can choose this rectified linear unit. It is also being popularly used. But you observe here, even though we have represented at a Z is equal to 0, this output is 0. Practically at Z is equal to 0, the output is not at all 0. For Z less than 0, yes, this output is absolutely 0. For Z equal to 0, and its output is 0.0000, some small value is there. There is another activation, we can take another activation function, that is leaky rectifier linear unit. What is the difference between normal rectifier linear unit and a leaky rectifier linear unit? In the leaky rectifier linear unit, for the negative values of the Z, we will get a small value as output, maybe 0.01 portion of the Z. Okay, right. So these are the functions we have discussed now. So the first one, sigmoid function. The sigmoid function output always ranges from 0 to 1. Whenever we are trying to get the negative values, we are going for the tan H function. This value is ranging from -1 to 1. But when we expecting the slope should not be 0 with after the Z value, example, after Z value is equal to 4.6, here the slope of this function is becoming 0. Then we are going for the rectified linear unit. The maximum value can be Z, and the leaky rectified linear unit, in the negative, for the negative values of the Z also, we are getting the output, a small fraction of the output. These are the different functions that are being used in the deep learning for the neural networks. Now observe, we have taken a sigmoid function and we are finding the derivative of the sigmoid function. The derivative already we have calculated. The derivative 1 by 1 plus e to the power minus Z, it is a into 1 minus a, or g of Z into 1 minus g of Z. So you can observe. We want to check at Z is equal to 10. Here I have taken. We already know at Z equal to 10, already this curve became constant. The slope should be 0. Yes. At Z equal to 10, the output is 1. G of Z is 1. If we substitute G of Z is equal to 1, At z equal to 10, the differentiation is becoming 0. Similarly, when I substitute minus 10 also, the differentiation is becoming 0. This is giving the indication that after a particular value of z, some 4.6, the differentiation of this curve is becoming 0 because there is no change. Similarly, when we take the tan h as an activation function, before going to tan h, we will calculate the differentiation at z equal to 0 also. Now you observe, at z equal to 0, the curve has some slope. How you know the slope at z equal to 0? We take the tangent at z equal to 0 and we will find the slope of this tangent. At z equal to 0, if you substitute z equal to 0, the g of z is 1 by 1 plus 1. The value is 1 by 2. Now, if you substitute this 1 by 2, then at z equal to 0, we got the differentiation of this curve as 1 by 4, which is indicating that at z equal to 0, we have some slope. Only the slope is existing in between minus 4.6 to 4.6 for the sigmoid function. Now we have taken the tan h, the hyperbolic function. For this hyperbolic function also, it is becoming constant. Now we are taking same 10 and minus 10. We have observed for 10 and minus 10, the differentiation is becoming 0. At z equal to 0, this curve is having some slope. That slope we have obtained as 1. When we use the rectified linear unit, for z less than 0, for z less than 0, the differentiation is 0. Why the differentiation is 0? Because the value itself is 0. For z greater than or equal to 0, the differentiation is 1. Why the differentiation is 1? Because whenever we are taking the value, whenever we are differentiate x with respect to x, the differentiation is 1 only. So it is indicating that whenever we can take any value, the differentiation is not becoming 0 only for the rectified linear unit. That is the advantage. That is the additional advantage of the rectified linear unit. Even if we take the leaky rectified linear unit, we can say the derivation of the leaky rectified unit is also not 0. Even if we take the z less than 0, the derivative is 0.01. Even if we take the z greater than 0, the derivative is 1. Why for z less than 0, the derivative is 0.01? Because for z less than 0, we are taking the function as 0.01 z. At z equal to 0, practically we cannot define this function because it is 0.00000 something. So if we find the differentiation at z equal to 0, similarly we are getting it as a 1. So this is how the ReLU giving an additional advantage to find out the activation function whenever the z value is changing. For the long values, maybe 100 or 200, the normal sigmoid and tan h functions, their slope is becoming 0. But we can use this ReLU rectified linear unit and leaky rectified linear unit only as hidden layer activation functions only, because their values are ranging from 0 to z. You have to remember, our output should be either 0 to 1. The final layer, the last layer, we should definitely use the sigmoid function only. In between, we can use the hidden layers activation function, maybe tan h or maybe ReLU, depending upon our requirement.